This is a future-proof mindset, meaning that with today PCI Express Gen 3 being more or less the adopted standard, PCI Express Gen 4 is a doubling of that data rate, and PCI Express Gen 5 is yet another doubling of that data rate. And so that's exactly the target that we took on with the Samtec Accelerate product. So PCI Express Gen 5 and beyond was our target for the application need. With COM-HD, a 10mm stack height was preferred. And then of course, the contact scheme was designed around the power requirements that are required for COM-HD. So Accelerate is the connector of choice, and the connector that really we started from the ground up, meaning that we started with a lot of experience with a similar interconnect platform, but we started with the breakout region, because even if you have a incredibly fast interconnect, if you can't route the traces from the interconnect, then that creates a lot of limitations for the interconnect itself. So we started with the breakout region, and we focused on hitting the high pin count, the density requirements, and the performance requirements. And then of course, Samtec has a very good track record of working collaboratively with other interconnect providers. And so multi-sourcing of this interconnect is a big part of the strategy, and that will also enable a lot of wide adoption of this interconnect in the COM-HD platform. So the key with Accelerate from an open pin field standpoint, we use that term a lot, but just to graphically show that a bit better, it's this connector, depending on the pinout requirements, it's suitable for differential pairs, for control signals, and for power signals. And so there's no limitations within the connector in terms of having predefined sorts of signaling. And so the open pin field provides a lot of flexibility for this interconnect. So also, a connector, it needs to be designed for its end use. And so there is an ease of processing with the Accelerate interconnect in terms of its ability to self-center on a footprint. Because as things get smaller and as pin counts get higher, of course that can also create a lot of registration challenges within modules. And so our interconnect is designed to have incredibly tight registration with the footprint, because when you're dealing with a module that has multiple interconnects, you need to make sure that you have a product that can reflow with a lot of accuracy to the footprint on the printed circuit board. And as I mentioned before, we started with the breakout region, and then we built up from there. And within the breakout region, we have row-to-row spacing that enables